All right. Hey guys, good morning. As always, we at our venue are so happy to have you with us, and we want to remind you that we're part of the same team with everyone out there using RF equipment. And what we specialize is certain products, yes, but we also specialize in training and knowledge and just communicating a lot with our customers and new people who may not know about us already. So my goal today is to share with you what has worked for me over the years. And this is an approach to when you're doing an event that's already set up, or you're in charge of setting it up, or you're in charge of selling someone a lot of equipment, or even a small amount of equipment. We need a fundamental approach to setting things up for success. So I do call it Richard's rules, but it's like it falls into it's a handful of points here, and I do narrow it down to three main important ones, which I'll show you. It's going to come up here, but it is very similar to how we approach audio and sound coming into a PA system, recording. It's signal to noise. We want to focus on that, and as a professional or a technician, whatever your role is, we're supposed to detect and get around the problems that actually destroy our system or make our signal to noise bad. Our best products are our best signal, or when we produce sound, um, and this is with everything with video and sound, we want it to have better signal to noise. So let's focus on that. So, all right, now, oops. Um, just to remind you, we are here to help you. We believe we are very good at helping you understand and achieve good wireless and in-ear systems performance. So yes, it does. It can help things when things work well. They do sound better. It's ultimately what we want. We want no noises. We don't want any weird stuff happening. So we can conquer that if we approach it correctly. Um, one thing we do get to, we have a lot of emails that people bring to us, they explain what their problems are. What are their hurdles? So no matter when, just feel free to email us at info at radioactive, or I'm sorry, info at ourvenue.com, and you will get a response quickly for anything you got to come our way. So just share with us what your challenges are, even after today. Okay, so let's approach successful wireless. Let's talk about some key points. Before my three rules come up, I want to explain why they're important. So once we understand the fundamentals, we have confidence, and the confidence goes a long way. It goes into when you're trying to be hired for an event. It goes when you're trying to sell something to someone else. So the more we know, the better, the more confident we are, of course, and I think everyone wants that. The more we're prepared um, means the more we dig deep into a brand new installation. Again, this pertains to something brand new or in place. It doesn't matter. We need to be prepared for everything. We don't want things to be returned. We don't want things to fail on site. So the more prepared we are, the less stressed we generally are. Um, Now, the troubleshooting steps that evolve around the three rules are um, very similar to audio when we're discussing signal flow, gain, loss, signal to noise. So really, if you think about it, um, no matter what your role is when you're dealing with an RF product, think of yourself as a technician, and you're kind of an investigator at the beginning, the middle, and the end. And you basically tell yourself, I have one shot to do this. Um, why not? Why not raise your bar as high as you can and get it right the first time? So let's go into the rules now. So one more thing before the rules is let's also start thinking outside the box. Right now, we you may not have known this, but we've lost over like around 200 megahertz of spectrum over the last 15 years. We used to have a bigger playground to use all our stuff in, and that means it's harder to get things to work together. We have things that hurt our signals, and that basically leads to, well, maybe I need a variety of antennas to choose from. So, so you may have your standards, paddle or a omnidirectional antenna. Just consider what we offer too. We offer a huge variety of antennas. So we can literally say whips and paddles are not good enough anymore. You have to have a bigger uh, toolbox. Consider our antennas if you haven't tried them yet. We'll go over some of those in a bit here too. Our popular ones and one of the new ones. Number two, when I say relying on the database is not good enough, that simply means if we go to any program that any company has to give you frequencies that are available for your area, and you type in an address, what is missing is the actual information, uh, and that is gathered from a spectrum analyzer. So a spectrum analyzer is always going to help you merge the database with an actual scan, and then that's really what creates the most potential for uh, for deploying the most frequencies. We want to be able to deploy the largest amount that people are asking for. We want people want to buy it. So in order to maximize that, we have to start thinking more often. We need spectrum tools. So our venue started coming out with spectrum tools about a year and a half ago, and it's huge. It's like it's now people can really learn this because it's more affordable. Um, so our tools are the Spectrum Recorder and the RF Explorer Pro. So if you haven't considered buying a Spectrum analyzer, definitely do so now. These days you really need one because just typing in an address and getting a list of channels that are on air is not good enough. So I'm going to throw in some things that I think are pertinent to doing this work well, is that you have to be motivated. There's a lot of little parts and pieces. Um, you have to keep track of a lot of stuff. You have to walk around. Our job, and because wireless is wireless, we have to make sure it works everywhere it's going to be planned on being used. So a lot of it is testing and you know investigating what's going to happen or what do I need to do before the actual event starts. So whatever keeps you motivated, you are going to have to keep that up, that level up, in order um, to really make yourself stand out doing this job. You have to be extremely motivated to do it well. Okay, here are the three rules. I call them steps sometimes, but consider it as a three-legged chair. If one of these is suffering, then the whole RF system can go. So first of all, we have to consider the noise around us. We can't use our wireless mics and in-ears and devices with a high noise floor. So that means you have to understand that local television is still transmitted from high points of the city. Broadcast television is still out there. It's transmitting radio and TV with high power. Those signals will not play well with our microphones and in-ears. So avoid that. I'm going to get to how to avoid that. But some of you may not know that there's still TV out there. I realize that maybe this audience has a wide variety of expertise, but I want to just remind you that these rules apply to any level. It's just reminding us what to look for while we're doing our work. Rule two is we have to use high quality equipment. We offer that. Other companies offer that. The mic manufacturers make their stuff. We all know who makes what. We find that RF Venue is in the middle of a lot of communication with RF because we work with all brands. So consider yourself when you reach out to us that we're a good resource for a lot of information. So we'll explain to you further. Yes, you have to use good equipment, good antennas, good cables, good distros, good combiners. You have to know signal flow. When you explain your RF issues, you have to explain it with signal coming in with receive versus signal coming out for transmit. And lastly, if you don't coordinate frequencies properly or use the good tools, then you're really taking chances because what happens with poor coordinated frequencies that you get intermodulation. Intermodulation is noise created by your own products. It's the same thing when you get told to turn off your cell phones on an airplane. It's because those devices are creating noise because they're so close together and and they're not coordinated. It's all random noise. So coordinating for us for microphones and in-ears means that we are simply using a calculator to do it with. I'll explain those options later too. Okay, again, avoid noise. Well, what is local TV? Well, it's a 6 megahertz signal. Our traditional analog systems and some digital ones too are 200 kilohertz wide. So when I say the width, I'm talking of how big the footprint is in the spectrum. 6 megahertz is the width of a TV channel, and our microphones and in-ears are 200. So if we try to use our equipment over or on top of a TV tower or a TV station, the noise floor is too intense, it won't work. So we put our stuff in between. There are benefits of when you have a show inside versus outside. The inside shows do block some of the signals, so we get away with that. So outside shows tend to be the tougher ones, especially when you're in a high congestion environment. But just in general, you need to see the difference of the amplitude of your signal versus the noise floor of the TV station. That's why we need a spectrum analyzer. By the way, I'm gonna repeat, we need spectrum analyzers out there for everyone 100,000 times during this meeting here, but just bear with me on that. Okay, another view, if we avoid TV, we have stuff above and below us, and that just means we need to put filters in place. We have filters in audio. We automatically put on vocal mics, things like that. We want to get rid of signal we don't need. So with RF, uh, below us is a lot of noise generated from power distros and LED walls, things like that. On top, we have a lot of cell sites and towers out there which is part of the 5G network. That if you're close to that and your building is close to that, it will leak noise in. So bandpass filters are part of getting rid of the noise as well. Okay, so how do you see the noise? Well, here you go. We have spectrum tools. I'm going to touch on these quickly, but I am going to focus on wireless system builder too. So from left to right, the RF Explorer Pro, portable handheld battery-powered device. It also has tracking SMA, you can test antennas, filter, and cables as well. The Spectrum Recorder is a portable, very simplistic analyzer. You just plug in your thumb drive, or you can connect to it on a network. Or in the near future, you can use it with Soundbase as a real-time spectrum analyzer, which I'll talk about later. But the main thing too today, I really want to point out that with Wireless System Builder on the right here, you can import a scan into our free program. So again, you can merge the database with your scan. That's a huge part of how to do this better than maybe you've done in the past. Here's a picture of System Builder, and it shows that when I import it or enter an address, well, the red is TV, but the gray is what my spectrum analyzer picked up, and it shows you that there are some channels here which are not acceptable to put anything on. So you would have to, you can go in there and edit these and say, well, this is actually on the air. I'm going to recalculate after I clean this up. So I would say, again, nowadays, you can't just type in a zip code and pick frequencies. You got to get somehow a scan, and that means if you go back, if you sell people these devices more, everyone's going to have access to getting their own scans. This one is super small. You could send it out in advance. It could be in a replacement of a site survey. If you wanted to go actually do a site survey of the location you're going to be working in, and you are able to fly over there, we'll take one of these with you. But if you can't, send the Spectrum recorder. Okay. When we use our gear, we have to buy good stuff. We have to use stuff that has good signal to noise, that doesn't break. Obviously, we're here to help you with that. We appreciate everything you do with buying our items. We are proud on offering a variety of things. We have some really cool things coming out this year, and if you're going to go to Infocom, you'll see some of that. But consider us as high quality components and accessories. Here's a great example of one that's been out for about 5 months now. If you haven't heard this or heard about it, please read up on it. It's doing really well. It's the only really truly available antenna that in the for $360 is IP rated, outdoor rated, circular polarized, super small, super compact. It's loaded with features that you should consider. Again, it's doing real well. Just one of the items that stands out that I want to just remind everyone about. Now, the you can get these next two pages. You can get these from us, but it just shows you we do have a lot of a variety of antennas. Um, get to know them just like you do on when you deal with microphones and patterns and sensitivity. You might now consider having a couple options based if you move around from city to city, room to room, you might have a benefit of a CP beam and a CP stage, or even omni half wave antennas. Spotlight. The Spotlight is one of the most unique antennas around in a while, and now of course our DFIN. Just study this for a while and consider the choices that you may have. Okay, so let's remind ourselves why we promote circular polarized antennas. Um, the benefit or the difference is that it's picking up on all angles. And when I say angles, when your transmitter is transmitting and the antenna is emitting information or RF this way, well, the antenna that is pointed straight up, and it's kind of blurry, but let's see. You can you're going to get the weakest point right here. This is the strongest angle. But the circular polarized enables you to pick up all angles. And our DFIN will meet somewhere in the middle of a standard half wave dipole or a paddle and the CP beam. So remember, our products fit in a lot of little spots that do very well. So here's just an animation of when the transmitters start to change angles. The CP especially and our DFIN will keep those signals strong, those carriers strong. Okay. Again, spectrum analyzers. Everyone needs them. They're affordable now. There's no excuse not to have one. It's like having a multimeter now. It's like having a Q box for your venue. It's like having a main computer. No difference. Filters, of course, use them. Put them in your signal chain. People don't think about them right away, but they are truly their insurance for less surprises. Surprises, yes, you may have something other than TV that comes in your room that blasts noise unexpectedly. This will help you from having problems instantly. Remember, we're still talking about step 2, which is using good equipment. So here's our other gear. We have distros and combiners, and we have a 4-zone piece, which is a zone combiner. But just consider our distros for microphones, our combiners for in-ears. Um, the HDR line is a step up, so it's devices with better signal to noise. So they are priced a little higher, but they are definitely needed out there, especially if you're using a lot of um, channel count, a big channel count. Okay, if you don't use equipment correctly, or if you don't invest into distros and combiners, this is what you get. And I know this is it's probably less common, but you'll find that people don't combine or reduce the amount of antennas, and they basically get two problems here. They get all these antennas together are basically desensitizing each other, and they won't pick up as well. Plus, they're near noise, they're near power supplies and things around this table that can cause noise. So why put your antenna there? Would you put your microphone here if you're trying to mic someone directly that's farther away from you? Well, no, you put your antennas away and in the right spot. So this is where you go, well, okay, do I use a DFIN? Do I use a CP, two CP stages? How do I know what to use for receives? Well, it depends on the room size, inside or outside. So not one antenna does everything all the time. There might be a time where you may choose between two. So choose your antenna, choose the right distro. So in this case, you have 20, 25 systems. Well, you probably would use distro 9 HDRs, maybe a couple of them. Um, this scenario here just explains that when you um, potentially put transmitters this close together, and especially if they're all energized, well, you're going to have problems with intermodulation. Even if you did do a very good intermod result, you don't get in the habit of putting things close like that. So let's go to coordinating. You can't just pick different numbers. I think we all know that. You can't just pick different frequencies. There's a mathematical relationship between the numbers. And if they're the bad mathematical relationship, then it causes noise. So you have to pick the good relationship, and that means using your calculation program. Um, it does the way we coordinate depends on what type of transmitter we're talking about and how close they are together. So what you do is you coordinate usually the items that are the closest together first, and those are generally analog in-ear monitors in a rack are the closest devices. Then you go to your microphones that are close together. Then you go to microphones that are not close together, and then you deal with if you're dealing with two-way radios, you basically don't coordinate them. You're just making sure they're not duplicating numbers. So it's a hierarchy of what to start with. Now, you do have to consider that digital devices like newer digital systems like EWDX, ULXD, Axient, EM6000s, everyone who makes a digital wireless mic is already helping us coordinate faster because we don't have to deal with intermods as much. Analog transmission produces the intermods the most. And you do have to like I mentioned, you need to start with the in-ears first because they're the closest in proximity. Um, but the reason in-ear monitors tend to not be digital is because the latency is a problem. Now, there are some out there, and there's new stuff coming out and stuff that's out now. So Spectera and Shure Axient PSM are digital in-ear monitor transmission and they work because the latency is finally in a good area for us now. Intercom's another thing. Most of the time you don't coordinate them, but if you're using, for example, uh, Radioactive Designs intercoms versus Riedel Bolero, well, the Designs systems you do coordinate, but you're operating in a different range. All the standard IP-based intercoms are usually in 1.9 or 2.4. You just you don't coordinate them though. You have to make sure your antennas are placed right. Again, two-way radios, we don't necessarily coordinate. We just make sure that they're not duplicating and we Just keep an eye on them as far as spacing. Okay, we're going to finish this section of coordination here, but this is exactly what intermodulation is. It's if you get transmitters close together, they produce noise. If they're if the coordination is done correctly, then you have less of this noise in, and you basically move them away. Those spikes are going to be in different places, so away from your other frequency carriers. So it is very important to learn how to coordinate. At the very least, you're gonna, after this event, you should probably start practicing coordination with any of the stuff that's out there. And again, we have our system builder um, to use. What I want to show you, this is a carrier of this is an FM carrier that when this is an analog intermonitor carrier, FM, and it just shows you that it does modulate quite a bit. The new digital intermonitors that are coming out now are going to do a lot less. So just keep the analog digital decision for sure for your microphones. I would invest in digital ones now if you can. Again, a rack of in-ears is what you start with. Bread pans are what you use to control the transmitters when they're close together. It basically attenuates them enough that it controls the intermod potential quite a bit. Receivers, we don't need to worry about intermods on the receiver side itself, but we need to make sure they're not placed next to other things. So other devices that transmit, we should keep these away from. These are PSM, these are intermonitor receivers, so it doesn't matter that they're close together necessarily. And they don't need to be in pans on the tech table. So again, just remember, try to understand the difference of receive products versus transmit and the intermods potential with transmits close together. So what program do you use? Well, I'm gonna remind you that we have a free program on our website called Wireless System Builder. It's the only one that can you can. It's a very simple, fast program. It has all the major brands in there, and you can enter your scan. You can enter your scan to compare the database with the spectrum that you have recorded or traced in your area. Huge thing. What we can't rely on the database anymore. We got to use some sort of coordination program where we can enter a scan. So here it is up here. On the right of that, our Spectra, our RF Explorer Pro does do basic coordination. You can do a coordination with the RF Explorer Pro. It doesn't bring in the database, but it does tell you, it does bring in a trace and it works around it. Now, if you need to go to a higher complex program to scan or to coordinate, the main ones out there are Soundbase and Wireless Workbench. Those have a setting on them, which basically is how you really nail the intermonitor coordination, and that is profile variant and global IMD test. And I'll just show you Soundbase has the settings right here. So when you're doing numbers and you're trying to get results, start with the in-ears first and generally put, this is called 3 transmit thirds. And then you put the profile for robust. You see how many numbers you get? The problem, it's not a problem, but the result of being very conservative with your settings means it gives you less numbers. So once you get your numbers, you start backing off on them, and then you start coordinating the microphones and things that are farther apart. So that manipulation of the settings here has really worked for me. When I really tighten up with in-ear monitors with this, and I have the ability to do that to get the numbers I want, and it really pays off. That in-ear monitor system means that with this coordination setting, now I could walk farther away from it. It's more robust. So this is also on Workbench. You can find it on their lower half there. And this picture too, I just want to show you that this is a difference. This is at United Center in Chicago. This is the inside of the building. RF coming in, this is the outside. So that's why you need to know both. And in most cases, if you're not sure, um, on sound base and wireless workbench, you could pull in people's scans. You can people upload them on both, and you could borrow theirs to look at before you get your own scans done. Also, band planning. It is good practice to put in-ears separate from microphones. So just put them in different channels because if you have analog equipment too, you'll find that uh, in-ear monitor systems close to microphones, if they're modulating quite heavily, may be an issue. So when you're planning open channels, just try to separate them and do in-ear monitors separate from mics as much as you can. The thing about RF problems is they come quickly and they surprise you. So we need to react quickly. It's almost like when you need to act like you're a hawk. You're looking out for stuff all the time and you're planning ahead. It doesn't mean you're stressed out though. This just means you're on top of things. Like with anything else that has complexity, the more you are ahead of the game, the better are you're going to be prepared. So so you can eliminate potential for surprises if you're prepared. Another thing we do with once we um, tune everything, the step of wargaming just means that I'm going to put my transmitters in an unrealistic position. And what I do is start, I turn them all on and I look at the rack. And now when I turn one off at a time, if no noise is coming into that channel, then I move on to the next one. If I turn this one off and no noise is coming in, I move to the next one. That's basically testing your coordination. And the way to do it is simply just put them at least a few feet apart. They're never going to be used like this, but that's your own way of testing it before you walk it. Because the next step is walk testing. You have to walk the mics out in the places that they're going to be used because the truth of it is that the room and the shape of the room, the objects in the room will determine how it's going to perform, how your transmitter is going to perform in that spot. So you have to test it in the exact spot. There's a feature called timeline or record that Workbench has. Soundbase is going to have it. You can record the performance of your antennas and go back and look. I have a little video for that too. Um, the other thing, you have a spectrum analyzer there. You need to be able to see it. You have it next to your rack. You have to have it tuned to your main frequencies, and you bounce between all of them as you get up to the point they're going to be used. So it's good to have access to your spectrum analyzer and your mic rack on the network with, let's say, Soundbase or Workbench. You could see all your devices on the network, then you have some insight. Now, once everything's set up and you walk test it, you still need to keep your eyes and ears open because some people in some events they bring up random wireless equipment that they're not approved, or they don't realize that it's going to have an effect on the whole show. And no matter what your event is, you just need to be aware of people bringing in equipment, other equipment. Here's an example of a walk test. It's just I'm this is me. This is a Mandalay Bay Ballroom, 65,000 square foot show, but I'm walking every area as much as I can, and I do that with every microphone and every in-ear system, in-ear monitor. Okay, this one. Hold on a sec. This is the timeline. If you haven't yet, I'm just gonna basically describe it. You go into Workbench, or eventually you're gonna go into Soundbase. You press record. You play it back, and you can see what your antennas were doing, how they were receiving. Okay, this is tuning into your main frequencies. Keep them where they fill the screen. You may not be zoomed at all of them closely, but you see all the main ones. And now you have a reference. And this shot right here definitely applies to if you have a problem, this is the first place you look. If you're having a problem during a show and you don't know if it's audio or RF, then you need to look here first. So let's go through examples. We're going to finish the presentation here with some examples of what to do. And these examples are very generic, but really it's most people describe problems in a very generic way, and you have to investigate what it means. So if you hear swishing sounds, well, what is swishing? Well, it probably means their reception is compromised. So what do you do? Well, apply the rules of RF. You have to go. The first thing you always have to do is get a backup ready. If you don't have a official backup, then everything you do beyond that is no good. So you have to react with a backup. Always keep a backup for everything that's critical. So Anthem mic, get a wireless backup. Get a wired backup. Um, any microphone for the main talent should have a backup something. So figure out what that is, grab it. Now you immediately look at the spectrum analyzer. You see if the carrier is still there. Is it fluctuating? What does the noise floor look like around it? Are there other transmitters nearby that are suffering as well? Because if it could be one transmitter that's suffering or a whole bunch of them based on noise coming in. Um, so you're focusing on how quickly you can get an answer for this problem, and if it's Mike, you see if anyone else is having the same issue for in-ears. Make sure if it's more than one person having an issue, then you know it's probably your main antenna. You got to figure out which antenna it is. Is it the receive or transmit side? So rule two, you're checking hardware. So yes, check the antennas on the receivers for in-ears. Check the antennas on the body pack transmitters for microphones. Check your main antennas. Reach up and grab the BNC and make sure it's twisted all the way. Have access to that. The last resort is to move to another frequency, but ultimately your backup mic or backup transmitter should be on another frequency. Okay, what are swirling sounds? This is a common one, especially with analog equipment, is if you duplicate your frequency on two transmitters and you forget that to either turn one off. A combo system is famous. Like if you have a body pack and a handheld tuned to the same number, and you turn them both on, you'll hear this. Now, this happened to me with just someone was handed out the frequency we were using at a game, and I caught it because I saw it on on Workbench on the monitoring page. So the swirling sound just means it's most likely someone stepping on you 100% directly. Figure out what your backup mic is. Uh, if you have time to investigate the swirly sound, you turn off your transmitter and see if someone else is right there with you. If you can't, then just move to another frequency. Now the issue with uh, having a direct hit means that you can't see the frequency carrier. You can't see the two signals because they're so buried within each other. So that's why looking at the your software, your monitoring software is the key here. This is what this is. So I could not see on the spectrum analyzer that I was having a direct hit, but the monitoring feature on Workbench showed it to me right away. So ultimately we switched to this number. We had no time to investigate this as an issue. Here was the offending frequency coming in. Super small, but it was enough to cause a lot of problems. Okay, my mic or IFB stopped working. Well, this can go anywhere. Remember, this could be audio or RF. So you have to determine, is it audio or RF? Is it the cable coming from your headset to your body pack transmitter? Is it RF related? So get your backup ready. Look at your spectrum analyzer, make sure your carrier is good, and then start going, well, it's probably audio. Is it the batteries? It could be something very simple. All of these examples I'm giving you have to be done in seconds. Like you have to be super confident and don't hesitate. You can't hesitate doing this stuff here. So if you would like, I could send you this to review later if you email me. But there's a lot of just reminders of what we should be doing when we're troubleshooting, especially if there's an audio issue. The most common thing is someone says, "Hey, Richard, you gave me a bad frequency," and then I show them on the spectrum analyzer. I show them, well, look, it's clean. The noise floor is low. It's probably audio. And a lot of times they have a poor cable. They're just too far. They're sending line level too far. Um, they have a bad microphone cable somewhere, or on their headset cable coming down, things like that, or it's patched wrong. So we have to be good audio engineers. You have to be able to jump right in, no hesitation, and listen to any audio issues and learn how to pick it apart. Okay, crackling. These are the common things you might hear. Like I said, well, yeah, you gave me a bad frequency. Well, let me show you that it's not. This is why having a spectrum analyzer in to show is key. So I talked about this already. So now let's review. Please get a spectrum analyzer. Pick one. Start with one. Just try to invest in one somehow. Um, Practice using coordination programs. Soundbase, our system builder. Our system builder is so easy to use. Just go on our website, practice. Try to practice importing scans so you can merge the database with your scan. That's a huge step that you should be doing now. Um, Remember, you may have now a variety of tool of antennas in your toolbox. Consider buying other antennas for other purposes, just like you have microphones or different screwdrivers. You need a couple of antennas sometimes. And please don't forget about bandpass filters. So remind again, if you want, I could do one-on-ones with on Zoom with coordination, with using System Builder, with using Soundbase. I can help you design uh, your setup right from the beginning. I can help you troubleshoot if you're in the middle of it and you just can't figure things out. We're here to help you. Uh, Don and Bob and I are here every day. You wouldn't believe how many calls we get to just help people make their system better. And that's why you should definitely consider our venue because we are huge on the customer service side. We feel that we are quick at responding and we get a lot of good responses from our customers about it. So that's all I have. Do we have any questions, Adam?
Absolutely. You guys sent a lot of questions and more in every one of these webinars. Certainly for troubleshooting, we always find there's way more questions. So we've handpicked a bunch. I'm sorry we can't get to everybody's question. Again, as Richard said, we're all here to help, whether it's a one-on-one consultation, training, more advanced troubleshooting, whatever you need, our team is ready to help. We do a lot of project review day to day, as Richard said. So whatever you got, let us know. Just email us at info@rfnu.com, or you can reach out directly to Richard or myself or Bob or Don. We're all friendly and happy to help. So without further ado, let me start calling out the questions. From an audio engineer, sometimes I have wireless Sennheiser units that will scream RF noise when powered off. How can I maintain RF interference?
Okay, so right there, you may have an analog system, which the analog systems have a traditional squelch circuit. The squelch circuit is like a gate that lets in more RF or less. If it's set too high, meaning your threshold's high, it'll let a lot of noise in. And over the years, people have developed those with a pilot tone or a tone key to help not just let anything else in. So if you have a digital system, the digital systems are better at squelching. They do it a different way because they're they're determining errors. And if they sense an error, then it will mute the receiver, like a digital error. So analog systems it's most likely you have an analog system. All you have to do is just find how to adjust the squelch in there and start turning it. If you turn it to the right, you're basically lowering the threshold for what's coming in. So let us know what you have, and then we'll help you with that.
Excellent. This question comes from a systems engineer. What are the best RF practices when mixing wireless transmitters and receivers?
Okay, going back to analog versus digital. If you have analog in your monitors, if you're talking about product where the products are physically close to each other, um, what helps you enable to do that though is if you do a proper frequency coordination um, to eliminate the noise, to reduce the noise level. So you have noise coming from inner monitors close together. The inner mods will create this noise floor. It comes up. If you coordinate properly, it'll lower that. So that means if it's lowered, now you could put the two together closer, maybe in a rack, the same rack. It just depends on how your coordination is done. The coordination is can make or break a system. Um, and yes, you have to be aware of what is close to your RF devices. Speaking of closeness, you don't want to put your transmit antenna behind your mic receive antennas. That's that's worst case. The best thing to do is just put them side by side or put your transmits in front of the receive antennas. So that's think of placement and where things are next to each other.
Excellent. All right, this question comes from an audio technician slash RF coordinator. How does encryption work when using it for my wireless Shure lav mics? Does it produce any delay?
So anything digital will have a little bit more latency. And the cool thing about modern systems, so again, EWDX, ULX, 6000s, there's a new SLX, um, Electrosonic. Everyone has digital systems now. There's new from DPA has one, um, tons of them. They now have low latency. So encryption and latency are not an issue. And if I were you, I just look at the specs and just compare the latency spec for each one, and then honestly, you just need to consider, how what everyone's doing and decide on your own which one would work for you. Because they're all doing very good now with that. There's no latency that's concerning.
Excellent. All right, this comes from an event production company. Recommendations for antenna mounts in touring rigs,
Ah.
monitor mixed position options, front of house, etc. I don't always have a lot of room.
So this is a Manfrotto Magic Arm. I know it's kind of blurry, but these are 100 and something dollars. They're not cheap, but they're really the best way to get the right angle. And you can mount it to truss. You can mount it to speaker stand. The clamp is pretty wide, so but the movement you get with it, you really want the right angle. Um, there are tons of other mounts, yes, and people sometimes use just mic stands, and it. I think the most important thing is to make sure you get some sort of angle on your antenna, and you get it at least 5 feet above your head. So the reason I picked a magic arm is because you can get that angle you want. Um, Doesn't mean you always have to have it. Again, if you want a permanent mount, K&M makes a nice little flange 1 footer that has an angled end. It's a ball joint there. You can angle the antenna the way you want. So, regardless if it's integration or install or live sound, um, start with those. And you want them, of course, to last. You don't want to drop them and they fail. So, you know, buy it once and then not have to do it again.
Awesome. This one comes from a systems designer and trainer. Coordination best practices. Best way to solve a channel with an interference issue.
Yeah. So if you follow the three rules I mean, coordination starts with being on the right TV channel. So I'm going to go back. If you try to put a microphone and you try to coordinate over high power or low power TV stations, you're obviously going to have a battle. Your building does affect the way these look on your analyzer, but try to maximize the lowest noise floor for everything you got. And that means if I go to here, well, I'm going to use these channels first. And if I have to, I may go on some of these higher ones if I have to. But so prioritize. And so then getting the noise taken care of right away is the key to adding numbers. And then beyond that is when you start to do the coordination part. Here, one second. Let me go back. You need to figure out the um, the IMD settings. I'm almost there. Right here. If you learn how to use these settings, you'll be able to get a more robust frequency coordination. So if you want, like I said, I could show you this over on the Zoom, and I could explain to you why starting with in-ear monitors with this first in general gets you a more robust in-ear rack, then you move on to your mics. So again, get rid of noise and coordinate properly.
Awesome. All right, this came over just now. If my budget is a little smaller, are there any spectrum analyzers that can be recommended? I understand RF Venue is the best. Thank you for that. And also, thanks for answering my question.
Yeah, there was a time where I could only afford a certain one, and I bought the original RF Explorer. Then I bought another one from the UK. Then I bought I keep going up as I um, you know get further in my career, and I have a couple like a Regal one. Regal's made in China too. It's a good one though. So you have to ask your peers what they're using. There are some that are super tiny that you can use. They're just quirky. You have to restart them a lot. Um, if you were to invest in anything right away, I would say consider the Spectrum recorder because you are going to be able to get it into your computer. This is right around the corner, and I know that everyone's dying for this to happen because now. So I'll show you. I'm going to go to. Let me share this with you. One second. This is Soundbase, and I have the very inexpensive one that's it's called a Tiny SA, but it's like my backup of my backup, and it's coming in real time to Soundbase. The Spectrum recorder is going to be able to do this very soon. So that would mean um, you have to decide if you want how you want it to come into your program and how many the price level of your Spectrum analyzer is going to determine how many times you have to mess with it, fuss with it. So I would try to set my best advice is just to spend a little more. You could spend under 1,000 for a Spectrum recorder and get Soundbase Pro and use Soundbase and wire and System Builder, and you're set. You're set for a long time.
Great. Well, I think you answered the next question of best system for RF coordination. And just to bolster Richard's point, the Spectrum Recorder is 799 MAP, and it is really, really easy to use. It's very simple to get the scan data. Almost anybody could
Yeah.
do it, right? I mean, that's the idea. So demystifying something that was once complicated is no longer difficult with Spectrum Recorder. So you don't really need anything, right, Richard? You just plug it in and get a thumb drive to extract the data. So I don't think
Yeah.
it could be easier,
Yeah. The,
actually.
the, the thing about that device really is, and now it's going to be available in real time. Real time, you don't need real time fast reaction all the time, but if you're on a high end gig and it's like super, yes, you need something real time. But that's why we're good at RFNU is really good at putting things in a spot where there's a huge market for it, and that will fill the Spectrum recorder will fill that for sure.
Awesome. Well, great, guys. That's about all the time we have. If there's any other questions, feel free to put them in the questions and answers. Bob Lee and Don Boomer are on and they're ready to answer, as well as myself. and we can call it out for Richard just the last 5 minutes here. But we will be sending you a feedback survey about how we did. We really want to hear your feedback about what webinars you might like to see in the future. This was part one. We do have part two coming soon, so keep a lookout for that. And again, if you have any projects that you're working on that you're confused about and need some help on how our venue might fit into that or how you could utilize our venue products, definitely just email us at info@rfvenue.com. You're going to get the whole team. So we're very quick to respond. You could certainly use our contact form on our website. And as Richard said, we always do one-on-one consultations and project review for anyone, whether you're a business selling wireless and installing wireless or you're a user of wireless. So we don't mind. Always reach out to us at any point. Oh, we've got one more question from Rick. Differences between Soundbase Free and Pro. Is the Pro version worth the cost for an installation application?
Yeah, so so Soundbase, again, it's owned by Sennheiser now. They're supporting a lot of people with it. So with that, you can monitor, sure, Sennheiser and Wisicom. You can monitor in their system. You don't have to go to separate monitoring windows. And you could put the real-time devices. So TinySA Spectrum Recorder can come in real time, and that's what the Pro gets you. Plus, you could work offline with the Pro one. So if you're on the airplane, you can do whatever you got to do and then sync it. When you get online, it basically syncs. So it is something that, so just a bit of history. Remember, there was a program called IAS for a long time that everyone used. And so it was IAS and Workbench. Now it's Soundbase and Workbench. And just don't forget, we're the only people, our venue, that has our free one that can import scans as well. So again, we fill the gap here. So I would have, several as your tool. I mean, consider Soundbase, consider System Builder as like your go-to. Couple, just pick a couple. But yeah, it's worth having.
Excellent. Well,
Cool.
that's all the time we have for today. Again, just feel free to reach out to us anytime, call, email, whatever you like. Thanks so much, Richard. This was a fantastic presentation. We will be posting this on our webinars page for future reference. There's a lot of information here, so you probably want to watch it again. But again, we're always happy to help in any way. So thanks so much, everyone. We really appreciate your time, and definitely look out for part two, troubleshooting a new wireless system. So that will be exciting. Thanks, Bob. Thanks, Dawn. Thanks, Richard. And thanks, everyone, again.